Hello, this is Mr. Craig, and I've had a few students ask about how to perform the calculations for the Hydrate lab, and I thought I'd run through a sample set of data here to help explain the calculations. You can pause the video, rewind it if you need to. I'm going to move pretty quickly on this. What I have is actually a nice sample set of data here. It's not actually a set of data that any of you should have. It's some data that I collected. And so don't be upset if your values are different than mine. The whole purpose of this video is to help you perform the calculations and complete them. I'm going to leave the post-lab questions up to you to let you discuss with your lab partner, so that's up to you. But let's go ahead and go through this. So what I have is the mass of the evaporating dish that is empty was 55.25. The mass of the dish and the hydrate I had is 57.21 grams. The mass of the anhydrous, which again is with the water evaporated off after the first heating, was 56.59. The mass of the anhydrous, and I only performed 2 heatings, the final heating was 56.53. So really I don't even need that data right there. So let's go ahead and get to the calculations. And again, when you do your calculations for the lab, be sure that you actually do these on a separate sheet of paper, write them out neatly, organize your calculations in such a way that are actually showing the units. So don't just show me numbers, don't just show me answers. In other words, I don't want to just see values in this area here. This is what you'll actually write down after you complete the calculations. So looking at the first calculation, it says the mass of the hydrate in the dish. So what we're going to do is we're going to take the difference of the dish that is empty and the first weighing, which is the mass with your hydrate. So we'll take the difference of those two values, and I've already completed that calculation down here, and I got a value of 1.96 grams. Yes, I agree that it is over the 1.5 grams that you were responsible for, but that's what I did. Alright, so that's the first calculation. The second calculation is the mass of the anhydrous in the dish, which means after the final heating. So we're looking at our final heating versus, or the difference of the final heating and the dish, so that I get just the anhydrous. And again, the anhydrous is after the water has been evaporated, as best as you could do it. So that's calculation number 2. And in this case here, I had 1.28 grams for my anhydrous. Again, the anhydrous is where the water has been evaporated off due to the heating. Looking at calculation number 3, it says the mass of the water lost by the heating. So we no longer look at our data to get these values. We're actually going to take the values that we have in calculations 1 and 2 to determine how much water was removed. So, and again, in calculation number 1, we have, this is our, and actually it's the hydrate, so it has the compound and the water attached. The second calculation was just the compound itself with the water evaporated. So take the difference of those two values, and in my case I got 0.68 grams. So we have some data here, which is kind of nice. The percent of the water lost by heating. So we have our percent that we just lost, which in this, our amount that we just lost due to the water is here, and this is our total sample. So we're going to take the 0.68 grams of water and divide it by the hydrate in this calculation. So calculation number 4 should look something like this. And again, don't get upset if your values are not close to mine. Doesn't necessarily mean that my data is correct. So I have a percent that is around 34.7%. Again, you only need to show one decimal place when doing that. Looking at number 5, the moles of water lost by the heating. So again, we're going to go back to our calculation here where we have the mass of the water, and we want to find out how many moles that is. So again, find out what the molar mass of your water is. And again, so we're going to take our amount of mass of water, divide it by the molar mass of the water, and there's my moles of water that was lost. And again, we're going to need that to determine the empirical formula for our compound, so we have our moles of water here. Alrighty, so now we have our moles of water, so now we're ready for number 6. Empirical formula for the anhydrous from the given information. Again, the given information is right down here. So that is the information that we're looking at. So you have your percentages here for our copper, sulfur, and oxygen. So again, since it's a 100 gram sample and you're not given any other information, just go ahead and make that a 100 gram sample because we're mostly interested in the ratios. So with number 6 is our calculation. So what I am showing here is we took the percentages, changed them into grams, divided by the molar masses, which you'll find on your periodic table. I got these values for my moles. Again, to find the ratio, divide by the smallest number. Looks like in this case, the smallest number is my copper. So I'm going to divide those all. This is like a 1.00000 something. So that is going to be 1. Where down here it is very close to 4. So our empirical formula for our hydrate is CuSO4. So we have 1 copper, 1 sulfur, 1 oxygen. Number 7 wants you to determine the moles of the anhydrous from using the empirical formula mass. So again, we have our mass due to our anhydrate right there. So we're going to start with the 1.28 grams. You just found out that your anhydrate has an empirical formula of CuSO4. So start off with the 1.28 grams divided by the molar mass of the copper sulfate. And in this case, we get a number of moles of our CuSO4 as 0.00802. Again, don't freak out if your data looks a little bit different. That's fine. All right, and then the last calculation, we now have our moles of our anhydrate and we have our moles of our water. So there and there. So that allows us to find the formula of the hydrate. So what we're going to do is compare